In the last chapter, we were looking at ionic bonds. And remember, an ionic bond is between a metal and a nonmetal, and then you have electrons being lost or gained. So my metal, remember we talked about, loses the electrons, the nonmetal will gain the electrons. But everything is still trying to have that pseudo-noble gas configuration with the 8 electrons around it. Then we also talked about the metallic bond, and metallic bond is between a positive metal cation, like a copper, and its own negative valence electrons. Remember we talked about how those valence electrons are shared throughout all of the metals, but each positive is the same metal, unless you're, of course, talking about an alloy, and they're different metals. Well, those are the main 2 types of bonds. Now we've got the main 3rd type of bond, which is the covalent bond. Okay, so again, when we talked about why atoms bond, this was in that very first quiz that we talked about. Okay, remember that atoms bond to become more stable. All right, we want that outer energy level with 8 electrons. So like I just recapped for you, an ionic bond, you have where there are lost or gained electrons, that's the metal, nonmetal. Then you have a metallic bond, which is a positive cation metal and negative electrons. And then our last kind of bond we're going to look at is going to be the covalent bond. And these are the ones where atoms share electrons. Alright, so we looked at exactly what is a covalent bond. Like I just mentioned, those are shared electrons. And if we're going to remember which electrons we share, those are the outer or valence electrons. They are between 2 nonmetals. So remember, these are going to be the ones that are usually on the right side of the periodic table. Things like a carbon and a hydrogen, a nitrogen and an oxygen, chlorine and bromine, something like that. Okay. Well, just a little bit of terminology here. When we talk about a molecule, that word is really supposed to be used for 2 things that are covalently bonded. Now we're going to talk about one particular kind of covalent bond, kind of the easiest one to explain, which is why we start with it. We have what are called diatomic molecules, and these are just molecules that are 2 atoms of the same element that are, of course, covalently bonded. So the example here are going to be these 7 different ones. We have H2, O2, Br2, F2, I2, N2, Cl2. And I've had people remember these by remembering Hoberfinkel, like how I have them written here. Okay, these are ones you're going to have to memorize, not necessarily for this chapter, but for the next chapter when we start talking about reactions, because these are elements that are always found in pairs. So H is never just an H, it's always H2. You can also remember them by the I have no freaking clue, bro. I've heard that before. Any other little mnemonic you want to come up with that's going to help you remember these is good for me. But like I said, not really until chapter 9. For right now, just kind of know what they are, and they are the easiest kind of covalent bond. And that is because, if I see here, we have a fluorine and a fluorine. Fluorine, remember, is in group 17. It's one of those halogens. So it has 7 valence electrons. So if it wants to bond with itself, each one is going to share 1 to make them have a total of 8. And so when they do that, okay, we kind of draw these Venn diagram-like things because they're sharing these 2 middle electrons. It's not like the ones we're looking at in the metals and the nonmetals where we have the Na is losing and we draw that arrow to chlorine that wants to gain it. Okay, does not work that way. They are shared, not lost or gained. So we call that middle pair there the bonding pair. And all of these pairs of electrons that are around all these fluorines are called lone pairs. because they belong just to that particular fluorine. They're not shared with the other ones. But still, see here how we have a complete octet of 8 for each fluorine. So that's what you kind of want to put down here. And that is the simplest example of a covalent bond. So we're going to take a look here at single covalent bonds, and then we're going to look at the groups of the periodic table as to how many covalent bonds each type of element will form. And if we remember back to a single covalent bond, like I just said, okay, these are only one shared pair. So we can show a single covalent bond either like how these hydrogens have it. So I would draw a circle around this one, a circle around this one, and then these two dots in the middle can be a covalent bond. Or I can draw it with a line in between, be like H dash H. Either one of those will tell me that there are 2 electrons there. So let's look at how many covalent bonds things form based on the group they're in. Well, group 17, those are my halogens. Okay, these have 7 valence electrons. So they're going to form 1 bond between them. So if I look at a chlorine, it has 7. It wants to bond with itself. This chlorine has 7. So if they share these 2 in the middle, now I have a single covalent bond. So it's going to be chlorine dash chlorine. So each of these has 3 lone pairs and 1 single bond. Look at group 16. Okay, these guys have 6 valence electrons. Okay, and each one of those, like an oxygen for example, okay, needs to find 2 more electrons to make 8. So what they do is they will bond twice, or it will have 2 shared pairs for 2 covalent bonds. And we end up with oxygen also having 2 lone pairs. These have 8 around it. So it's going to share 2, 1 with each hydrogen, and then have 2 lone pairs for a total of 8. Now if we're in group 15, these guys have 5 valence electrons, and they want to have 8 total. So we're going to form 3 covalent bonds and have 1 lone pair. So the nitrogen, for example, it has 3 here that it needs to share. So it gets 3 hydrogens, forms 3 bonds, and ends up having 1 lone pair. If we look at the last group of nonmetals, which is going to be group 14, okay, carbon's a very good example. These guys have 4 valence electrons, so they can actually share 4 electrons and have 4 covalent bonds. And these guys are not going to have any lone pairs. So carbon here can take and share its 4 valence electrons with 4 hydrogens and have 1, 2, 3, 4 bonds, total of 8 things around it. Okay, so let's draw some Lewis structures for each molecule. A Lewis structure are just those things with the dots and the lines that we were looking at before. And they're kind of our introduction to it. When we look at pH3, phosphorus is in group 15. Okay, meaning it has 5 valence electrons, so there are 5. Okay, and it has 3 hydrogens here. So what's going to happen is this phosphorus is going to form 3 covalent bonds. It's going to share 1 with each hydrogen. Because hydrogen always has 1 valence electron. So we're going to go with something like this. P, H, H, H. You can also look at it with the dots. And this H is going to share here, and it's going to have 2. This H is going to share, and it's going to have 2. This H is going to share 1 with a phosphorus. And now phosphorus is going to have 8 inside its little circle. And each hydrogen is going to have 2 inside its little circle, and they're all going to share. Okay, chlorine is in group 17. It has 7 valence electrons. meaning that it only wants to share one. Well, that's good because hydrogen here has one electron as well. So now chlorine's got its 8, hydrogen has its 2, and they're going to share those 2 in the middle. One covalent bond. Look at SiH4. Si is in group 14, meaning that it's going to want to form 4 covalent bonds because it has 4 valence electrons. And look at this, we have 4 hydrogens. So each hydrogen is going to come along with its valence electron, and they're going to share. So now this hydrogen is happy, it's got 2, this one has 2, this one has 2, now this one has 2, and then the silicon has its 8. So we end up with something like SiH4. 4 H's. Put that part out. Alright, last few questions here. Identify the type of element that generally forms covalent bonds. So they're going to be non-metals. Describe how the octet rule applies to covalent bonds. Okay, like we're doing those circles there, okay. The octet rule, remember, means that I'm going to have 8 valence electrons around it. So it looks like a noble gas. When we draw those circles, the things have 8 around them, other than H or He, because they have 2. Okay, so here we're looking at that each element has 8 electrons around it, but instead of being lost or gained, they are shared. So they share to have 8 electrons around it, not losing or gaining like we do in a ionic bond. And the last question, compare and contrast an ionic bond and a covalent bond. Well, what do they have in common? What am I trying to get when I bond? Well, we're trying to get those 8 valence electrons. So they both have in common that you're trying to get that noble gas notation, or those 8 valence electrons around each atom. It's just how they get those 8 that makes them different. So remember, an ionic bond is going to be between a metal and a non-metal. And here we are losing or gaining electrons. I'm talking about a covalent bond. These are 2 non-metals, and they are sharing the electrons to get to 8. And that's our introduction to covalent bonds.